Welcome to this video about closures in Blazor. What are closures? When we write lambdas, or more generally speaking, if we reference a method through a delegate instance, and the referenced method either captures a local variable or a member of the class in which the referenced method is defined, the compiler has to create a class for us that encapsulates all the values that the method needs to run. This is called a closure. You may ask yourself, why does the compiler have to do this? It has to do this because in most cases the delegate is invoked after its creation. So the compiler has to provide a way for the delegate to know about its creation context. The other question that maybe arises is what has this to do with Blazor? It's not Blazor specific, it's more something C# specific if we use closures in loops. But because we define in Blazor often loops, it also has relevance here in Blazor. Now, to demonstrate the whole thing, I will create two loops. The first one is a for loop. In this loop, I will create 12 diffs, and every diff has also defined onClick event. I also define a field. And the purpose of this field is that we can set it through clicking one of the diffs. I have the same names, so I changed that to T. So T equals I. Now the second loop is a for each loop. For each int, let's say u in enumerable range we do the same thing here. So to see it a bit better, I style it. The first one I styled with alert danger. In a couple of seconds you will see why I chose danger for the first one. And the elements in the second loop I style it with the success class. So now you see the relevancy in Blazor. Okay, I forgot to give them the number so that we can see. So in here I have to start with 1. Okay. Now it should work. So if I click a green number, it works as expected. It gets assigned the number that is here. Now, if I click one of the red numbers, it always gets assigned 13. Why is that? That's exactly because of the closures. Because these are all delegates, they are getting invoked after we have defined them. And now they reference I, but they reference it after the whole for each loop has run, so I is 13 now. Now, how can we change that? We can just define a temporary variable for each iteration, and then we can assign this temporary variable to t. Now it should work. So it works as expected now. This was just a small reminder. If you find yourself writing a for loop and it doesn't work as expected, it maybe could help if you make a local variable and then work with that local variable in the lambdas here. Thank you very much for your attention.